the slight delay. I was having a super secret meeting with Andrew Taylor, and we've discussed, you know, how to, I don't know, brainwash you into doing things or whatever. But welcome to lecture 22, COMP1511 18s1, the end, quite possibly the last time that I will stand here and yell at you. So someone said yay. It's not a yay thing. So I'll go through some stuff about the exam and assessment and all that, and then we can do some revision at the end if there's time. There'll probably be time. I've put up a question thing on Echo 360 again, so put questions in that if you want. But before we get to that, I want to just take a step back for a minute. Why are you here? Right? Like, why are you in this room today? Why did you turn up today to my lecture? Exam information? Like, why are you taking this course, right? Why are you studying computing if you're studying computing? Shh. You know, like, why are you at this university or in Australia, right? So, anyone, why are you here? Like, why? Does anyone have a good reason? Does anyone have a reason why they turned up today that they want to share? What about computing? Like, if you think about it for a minute, why did you decide to study computing? Why did you decide, oh, I know what I'm going to do. I'm going to take COMP1511, the super easy course, super wham booster course. It's going to be great. It's hard work, right? So why are you here? Why did you want to try and do this? Any thoughts? Challenge yourself, yeah? Challenging yourself is fun. What about computing in general? Like, why did you guys decide to study computing? Any ideas? High in demand. I guess that's a reason. Is anyone here purely only because computing gets them a job and they have no other reason to be here? A couple, right? But I feel like, you know, studying computing, hopefully like most, if not all of you, have some reason, right, why you decided you want to study computing. How many of you are not from Australia or not from Sydney? How many of you moved to Sydney just to go to UNSW? Okay, I've got my hand up as well. I'm from New Zealand originally, and I could have just stayed there and got, you know, a student loan and had all my things paid for and not had to pay all this money to do studying and life and stuff like that. But I decided for some very strange reason to come to UNSW. Still not entirely sure. But it's been good, right? Like, I've found that studying computing here for me has been so rewarding, right? Thank you. I don't know. But like, why did you want to study computing? Does anyone have some thing they want to do with computing in the future, or a reason other than like, because I want money? Anyone? Yeah? Say that again? You want to work at the ASD? Fair enough. Any other thoughts? Why did you study computing? Why do you want to study computing? To help people. To help people. You might laugh, right? Like, ha ha ha, helping people, that's so silly. Helping people is great, that's why I turn up. Computing though, like, if you think about the impact that computing can have on helping people, right? How many of you have used Google Maps? How many of you remember the days before Google Maps where you had a paper map and you had to read that? My anecdotes are getting less and less relevant as you get younger and younger, right? But if you think about 10, 20 years ago, right, telling somebody, hey, I'm from the future and we have maps that show you where you are on the map in real time. This magic thing will appear on top of the map saying, hey, you're here. And it might say, hey, you know, your parents over here in this part of the map. And the map, it's the map for anywhere in the world. Like, it's If you talk to somebody 20 years ago, they would be like, no, you are crazy, like, go away, this is not realistic at all, right? But it's crazy what technology can do to help people. I mean, I think it's important to think about, like, what do you want to do, right? Hopefully you came here to study computing for some reason, maybe just because you wanted money, maybe because you thought computing sounded cool. Maybe you have, I've had some students with very specific aspirations, like they wanted to go on and make self-driving cars, one of my students was really into, or building robots or that sort of thing. But it's really important to stop and think for yourself, right? Just take a moment. Why are you here? Let's just have like 30 seconds of you actually thinking about that. So why do you want to do computing? Like, what is the reason for you, like in your, you know, your heart, your soul? Why are you here? And you might think this is sort of like a silly thing. Why is Andrew wasting time getting us to think about things that are personal, right? But if you don't ever think about this, if you don't ever think about why you want to be doing things, if you just sort of blindly go through life, you know, what do you do when things get hard? How many of you have found at some point during this course, things are really hard and you were like, this is real, I don't know what I'm doing, I just want to stop doing this, like this assignment is stupid. Why am I trying to write this friggin' AI, like, this is just not working, it's, right, like, but you're still here. Why are you still here? How did you manage to persevere through that? Right, maybe you've just gone completely brain dead and you're empty on the inside and now you're just here as an empty shell, right? But hopefully it's not that. Hopefully it's that you have some motivating reason that's driving you to want to continue to do computing. And one of the reasons it's really important to think about this is so that you have some motivation when you get stuck, right? Because things get hard. How many of you found this course hard at some point? How many of you didn't find this course hard at any point? Okay, we didn't push you hard enough, I'm sorry, we'll have to push you harder next time. Right, but this is a very difficult course, and maybe 20–30% of you have vanished from the seats, as you do. But it's important to have some sort of end goal in mind, like what do you want to do and how will this course or the thing you're doing help you get there, right? Because when things get hard, the assignment's really hard, like you have no idea what you're doing, you just want to stop and give up. It's important to have that thing in mind, like you know, have some, think about what you want to do when you get out of this and how this assignment can help you get there or whatever. I think that's about what I had for that question, but it's genuinely, do take the time to stop and think about why you are here, why you are doing this course, why you are doing computing, why you are at university, right? Don't just ghost through life, you know, breeze through life, never thinking about what you're doing and just sort of blindly doing things. And I guess the next sort of question, what have you done this semester? Right, it's been a hard semester. We have pushed you very hard. I know that at some other universities, right, the amount of stuff that we've done in this course, they would do over a year, or over more than a year. So we've, in just the space of one semester, you know, 13, 14-ish weeks, we've gotten you to do a lot. Please stop talking. You know, we push you hard. This course is hard. Most of you, hopefully all of you almost, have found at some point this course has just been really hard and you've gone, I have no idea what I'm doing. But it's having those, like, I don't know what I'm doing experiences that can help you, I don't know, build and grow. But this semester has not been easy. Like, this course has been hard, and the fact that you are still here is really fantastic. Like, the fact that you are still going, you're still persevering with this course. Like, the fact that you've made it this far is awesome. And I know one thing that matters to a lot of people are grades, right? And I appreciate that grades matter. If you fail a course, it goes on your transcript, and if you fail enough courses, they kick you out of uni, and that's all sucky and so on. But to me, like there will be students who came into this course, and they could have sat the exam before the course started, or they could have gotten full marks in the exam before the course started, right? And so if someone comes in here and they know everything already, and they don't learn anything new this semester, and then they get a high distinction, they have wasted their semester, right? Like if you come in here already being able to do everything and don't learn anything new of any kind, what have you achieved, right? But if you came in here, you knew no computing, you had never done any programming before, and everything was hard the entire time, and you just struggled and you worked so hard. You know, every lab you thought, you know, God, everyone else in the lab knows what they're doing, and I'm just sitting here struggling, I can't even pass, you know, question 2 of the weekly tests. But if you are that student and then you make it to the end of the course and you get a grade of 51 and you pass the course, then to me you have won. Like you have done, you know, persevering through and struggling so much, even if your grade is lower than someone who came into the course and knew everything, right? The fact that you have overcome that struggle and learned to program means that, to me, you have won. And I'm very proud of you. I think that's about it for that. So I guess where to from here? Did I even write things down for this? Okay, so I mean from here, right, there are future computing courses that you can take. So if you're doing a computer science or software engineering, computer engineering, like other computing degree, then you will go on and take further comp courses. If you're not a computing degree person, you can still choose to take further comp courses, I think, for electives, probably. But if you think about, right, the things you have learned in this course over the semester, you now have the required knowledge to do just about anything with computing, just about any programming. We've taught you the basic skills, you know, you understand if statements and loops and functions and all of this stuff. And from here, you can just teach yourself the required knowledge to do pretty much anything, like to make a website. How many of you have seen the really awesome TraderBot website, Fruitbot website with the interactive world? How many of you have seen that? That is the sort of thing that is within reach of you now, having learned programming. You can make all sorts of really cool things like that. You could, I don't know, make robots. I've done a lot of website stuff with like Python development, which is really cool. But basically, if you have an idea for something that you want to make, you now have the ability to make that. That's the power of computing. So I guess ... Thinking back to admin stuff, I didn't make my don't panic big enough. I should have made that even bigger. Let me zoom in. So thing number 1 in terms of admin is don't panic. The exam is approaching, the assignment is, due date is approaching soon, and you've got exams in all of your other courses and everything is hard. But don't panic, you are nearly there. The end is in sight. Assignment 3 is out now. Who has not started on assignment 3 yet? You make me a little bit sad. But I have good news for you. If you haven't started yet and you're confused, you don't know what's going on, have a look at the lab's exercise solution videos that one of the tutors has made, because they are fantastic and they will help you get started. Like, they go through the lab solutions for week 11, which are making an AI effectively, but they also talk about how you can take this and expand on it to make an AI. So the videos are fantastic, you should watch them. The very last weekly test is due on Saturday, and we still have help sessions this week. And maybe next week, I'm not sure. Zoom back out again. So again, like last week, I've got a question thing set up on Echo 360. So if you want to ask any questions in the second half when we do revision-y stuff, we can do revision-y stuff there. Okay, exam. Who wants to know about the exam? Just about everybody. Cool, you're in luck. All right. No exam, go home.
It's not wrong.
There we go. You turn it off and on again, and then it works. Excellent. So like I said, the exam. Cool. How do I view a PDF? No, left and right arrow goes back. Full screen. Cool, so these are Andrew Taylor slides, but I have going to talk through them. So in terms of assessment stuff, right, you're wondering about marks and all of that. So you already have your marks for assignment 1. For assignment 2, you can now view the auto-marking marks, so like the performance mark. Andrew Taylor looked at the submissions, like he started at the top and read the code and sort of went downwards and worked out, you know, people who got this tournament point score should be high distinctions, people who got this should be distinctions, and so on. So it wasn't based on the tournament points so much as he looked at the code and went, people with this code deserve this grade. It should be in line with what the assignment spec said. If your grade is obvious, like if the grade you have been given does not reflect how good your code is, then your tutor can like manually assess it and override their grade. If it doesn't compile as well, the tutor can assess it. Tutors will start on style marking soon, but they have exams as well. If you think about how stressed you're feeling because you have exams coming up and assignments due, they have exams coming up and assignments due and marking to do, so it's fun times. And then for assignment 3, it will be run in both single bot worlds and multi-bot worlds. So the multi-bot worlds will have all of the other students' AIs. And the marking will be sort of like if you do better in multi-bot worlds than single player worlds, you'll still get more marks and so on. Again, if it's not a fair mark, tutor can adjust, doesn't compile, tutor can adjust. You'll have the performance mark by the end of SUVAC, I think, so the first week of exams, style marking soon, tutors have exams. Cool, for the lab this week, one of the things to do is to complete the My Experience survey. It's really important that you do fill this out because, because it's really important that we have enough people fill it out that we can have, like, look, people filled it out. But genuinely, it's important to give useful feedback to us for the course. We also have a practice exam in the lab. I told my students this and they were just like, oh my God, an exam. But it's really important that you go along to your lab and do this practice exam because it's a practice of what the exam will actually be like, right? In the final exam, you're in what we call the exam environment. So you're on a CSE computer, like you're on a lab computer, but you don't log into your own account, you're logged into the exam environment. So you can't access any of your own files, you can't access the internet, you can access the limited set of things we give you. So we give you like a compiler and gedit and a terminal and a calculator and all these things. If you have never been in the exam environment before, when you go to the final exam, you will be like, what, this is different and strange, and how do I open this, and how do I do this? So I very, very, very strongly recommend go along to your lab this week and do the practice exam. It's worth lab marks if you do it, so you should do it and get lab marks. CA marks are good, but it's genuinely, you will get an opportunity to practice what the exam will be like, and if you practice it now, you won't have to waste time in the exam. Working out what it's like, we will release all of the practice exam questions and solutions next week, so different days and classes have different questions or questions from a set of questions. Your tutor can also help you with assignment 3. Cool, so looking at the overall assessment for this course, and this is in the course outline if you ever wanted to read it. The labs are worth 12%, 8% weekly tests, 6% assignment 1, 12% assignment 2, 12% assignment 3, 50% final exam. Importantly, the date of the final exam, I believe the provisional exam timetable, so the non-official one that came out at the start was wrong. So it is definitely on the 15th of June. The marks might be scaled a little bit to ensure an appropriate distribution. Sometimes marks scaled up a little bit. Scaling down was never done. That was not the right button. Cool. Come on, what are you doing? So, in order to pass this course, like, importantly, in order to pass any course, you have to get at least 50% in the course, right? That is the minimum requirement for passing. In this course, we also have a few extra things. You have to solve problems using arrays in the final exam. So you have to prove to us that you can use arrays to pass this course. Fair enough. Similarly, you have to be able to solve problems using linked lists in the final exam. So you have to prove to us that you can use linked lists to pass the course. In the exam, in the practical section, it will be clearly labeled, like, if you pass this question, this counts as a pass for the arrays hurdle, or so on. And importantly, there will be an easy linked list and an easy array question. I think there's more on that later on. You don't have to pass any other assessment item overall. Like, it's fine if you get 45% in an assignment or if you get 45% in an exam overall. The only requirement is 50% in the course, and you solve an arrays problem, solve a linked lists problem. Again, that is not the right button. Come on. Cool, so labs are 12% of your final mark. Each one is worth 1.3. Originally it was the best 11 of 12, but we only have 11 labs, so now it's the best 10 of 11. It's multiplied by 13.2 over 13 because you were possibly cheated out of 0.2 lab marks, so we've got that for you. It's capped at 12 marks, and you can see the current total excluding this week's practice exam mark in your class mark thing. So you can see what will probably be your lab mark unless you do better in this week's thing than you have done before. Cool. The weekly tests, come on. There we go. Weekly tests are 8% of your final mark. Each test is worth 1 mark. Best 8 are summed. Your current total, not including the current one, is visible in the thing, so you can see all your grades so far. Cool. The final exam, which I'm sure you all have been waiting to hear about, it's held in 2 sessions. So there are a lot of you, and we can't fit you all in the labs at once. So because of this, we have to have a morning session and an afternoon session. This will be on Friday, the 15th of June. If you have another exam, we will automatically assign you to the non-clashing one. So if you have another exam in the morning, we will automatically put you in the afternoon comp exam, because we know when your exams are. We'll send out an email on Wednesday where you can indicate a preference for morning or afternoon. So if you have, not a requirement, but a preference, so if you have, I don't know, there's a really good party on Friday night or something, then you can request to be in the morning session. If you have an important reason that you have to be in one, like a religious reason or something, indicate your preference, and then if that doesn't get met for some reason, email us and we'll fix it up. So if you have a really important reason, we will make sure it happens, and if you have a preference, we will try and make sure that happens. You'll find the exact time and location at some point before the exam, but it will be in the labs. You'll be told which lab. It's a 3-hour closed book exam, so you can't bring anything in. We will give you working paper. So you need to bring a pen, your student card, and optionally a water bottle. We'll give you paper. There's a calculator program you can use, all that sort of thing. The exam has a theory part and a practical part, so you should do both of them. And importantly, we release what's called a skeleton exam. So we release the actual exam paper, but we remove the content of the questions. So you can see, for example, question 1 is a multiple choice question that asks you to do these things for 2 marks, and so on. So we don't give you the questions, right, because then you could read the questions and do them before the exam, but we give you the exam paper itself, the structure of it. Are there any questions so far? Cool. So part 1 of the exam, you have to do it during the first 30 minutes, and you can't use a terminal, you can't use a compiler, you can't use anything. All you can use is the program that you enter your exam answers into, and the online documentation we provide. So the questions for this sort of thing, the purpose of this is that we want to make sure you can actually do coding related things without a compiler. You don't just type auto test and hit enter and over again to code. You need to show us that you can do coding things. There'll be about 15 questions, but there'll be short answer multiple choice. We're not going to ask you define abstraction or that sort of thing. It's not essay-based things. There'll be things like read through this code. What does this code print out? Or maybe something like, at the end of this code, what value will this variable have? or like what value of I and j will cause this or whatever. Like it'll be straightforward coding related things, not, you know, theory, essay type stuff. The practice exam questions in the practice exam this week have a good guide on what to expect, but the questions will be harder. So we intentionally made the practice exam questions be quite straightforward because it's just for you to get used to the exam environment rather than actually doing a real exam. Part 2, the practical part will be sort of 7 to 8 questions. They'll mostly describe a task and ask you to write a program or function to do that. So it will be like the weekly test questions you've had so far. You know, write a program to do X, Y, Z. Here's an example input, here's an example output. You might be given starting code, you may or may not be given test data or other files. Most or all of them will have auto tests, but just because you pass all the auto tests doesn't guarantee that you'll get full marks. Right, it's like how with the labs, we give you auto tests and then we also do our own marking tests later on. So if you pass all the auto tests, your code is probably correct, but that doesn't guarantee that you'll get the marks. And it's not sufficient to just match the examples, right? So if your code works for the auto tests and no other examples, you won't get marks. You must write answers in C. You can read the questions in the first 35 minutes as part of the part 1, but you can't do any coding in the first 35 minutes. So then the exam questions themselves in this part, questions 1 and 2 will be easy questions. So similar to the first question in the weekly tests, like create a simple C program, use ints and doubles, use scanf, use printf, if statements, loops, command line arguments, arrays. And I believe there will be an arrays question and maybe also a linked list question of this difficulty. But these will be quite straightforward. So one example, question 1. Come on. Read some values and do some computation. So for example, your program should read 2 ints and then should print a line with all the even numbers that lie between these two. Should be the even number and its square. Aren't those inconsistent? Whatever, but like read in some numbers and do some basic calculation. Another example would be read these command line arguments, calculate the sum of the integers or something. So quite straightforward things. Question 3 and 4 will be similar difficulty to the question 2 in the weekly tests. So things like fgets_c, read into end of input with scanf, fgets_c, use arrays to source strings, manipulate strings, do computations on linked lists. So revising for these, you should go through all of the weekly tests, all of the tute questions, and all of the standard like non-challenge lab exercises. Questions 5 and 6 will be similar to question 3 in the weekly test, so a bit trickier. You need to be able to read and write files, malloc, change strings, change linked lists. So you should revise, including the easier challenge exercises. Questions 7+ will be difficult questions for HD students. Complex programming using any of the features covered in the course, you should revise all challenge lab exercises except the first couple of weeks that were not puzzle challenges rather than coding challenges. Like the goal with the exam, right? The goal with the exam is that nobody will be bored during the exam. Everybody will have something to do for the entire exam. So if you're an HD student and you're going to get 100% in the course, questions 7 and 8 will be very hard and you can spend the entire exam on those. If you're aiming to get a pass, then you can spend all your time on the first few questions. Like the idea is that you will not be bored. You will be challenged. You will have fun if you are into exams. In terms of the hurdle requirements, so this is the you must pass arrays and linked lists to pass the course. So from problems using arrays and linked lists is cool. There will be at least 2 questions for each hurdle requirement, so if you can't solve one, you can solve the other, everything's fine. At least one of them will be in the easier questions, and a good strategy is to start out with the exam and do these first. Right, so start out, do the easy array hurdle, do the easy linked list hurdle, and then do the rest of the exam. And so you can know you've passed the exam. Pass the course. Cool. Marking for the practical section. We auto mark it. Make your program do what it's meant to do. We also hand mark it so that if your code is very close, you get, yeah. So if your answer is almost correct, but it's missing a semicolon or something, you'll get close to full marks. There are no marks for style or comments, but if your code is really hard to read, you're unlikely to get marks for it. Like, if you write ridiculous code with no indentation and all of your variables are called like A, B, C, D, E, F, it'll be hard for you to find your bugs. And it'll be hard for the person hand marking it to go, oh, I can see their code is correct, they've just got this bit wrong. Like, if they can't understand your code because it's a horrible mess, then it's harder to get marks. You're not going to lose marks for style, like we won't deduct marks for bad style, but if your code is hard to read and understand, then you will have a bad time and we will have a bad time. So the question was, why, if the stuff is auto-marked, why is there a delay between when the exam happens and when the marks come out? So reasons for that include they also are hand-marked, so if you don't get full marks, your code will be verified to see if you should. But also, it's not just like, have you passed the auto tests? Cool, you've passed the auto tests, you've got guaranteed marks. Like, we've got to go through, make sure the auto tests are correct, make sure the marks are sane, make sure, like, because if we said, okay, cool, here are your final exam auto test marks, and we'd made a mistake in the auto tests, it would be really crushing for you to know that you think you failed things when you didn't. So we don't release marks until we've gone through and like made sure that they are the marks they should be. You won't get marks for just writing a little bit of C code. You've got to substantially start to answer the solution to get marks. Cool. Are there any more questions about this stuff so far? Cool. We do not have any past papers. We do not have any past exam. No past PAM exam suitable guide. I think that translating to English from Andrew Taylor, he's saying that there doesn't exist a past exam that we could give you that would actually be suitable. I think. But the weekly test questions were intentionally chosen to be like the exam questions. And some of them were exam questions from last year that I wrote. Cool. So another important thing, if you turn up to the exam, you are saying, I'm well enough to do the exam. Right? If you go to the exam and then after the exam you say, oh, I had a cold, I didn't do very well in the exam, we won't give you special consideration, right? If you turn up to the exam, you are certifying, I'm well enough to do the exam. So if you are really sick, then stay home and apply for special consideration. How many of you don't know how special consideration works, just out of interest, because you're first years? Do you want me to explain that whole process? Or are you happy? Does anyone want me to explain special consideration? A couple of people. I don't know if they teach you this stuff anywhere. But basically, if you Google UNSW special consideration, there's a page, and then we wait. Do-do-do. 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 Imagine if the internet were fast. Life would be crazy. It's loading, it's just not loading. Okay, I'll let that load in the background. So I'll talk about that in a minute. But if you are too sick to do the exam, don't go to the exam. Get a medical certificate, see a doctor, apply for special consideration. If you become sick during the exam, and I'm sure there will be someone who is feeling fine and then gets sick during the exam, ask the exam supervisor to contact the lecturers and then talk to us and we'll sort something out. Provisional results will be made available when marking is complete. 1,000 exams take a long time to mark, so probably the 2nd of July. We'll send you an email announcing when the results are out. There will also be some times when you can view your exam and check your marking. So we don't release your questions and the answers, but you can come and review your exam with us, or probably with Andrew Taylor, and he'll go through your exam paper with you. Your final results will appear on my UNSW. Cool, so importantly, SUP exams. If you miss the original exam due to a legitimate good reason, then you will have a SUP exam. So there is a date, I think it's Friday before semester starts back, so like Friday of week 0 effectively. If you are too sick to do the exam and you genuinely were too sick, you can do the exam again then. If your mark is between 40 and 49, so you almost passed, and you've gone to 9 or more labs, you've done 8 or more tests, and you've reasonably attempted the assignments, you automatically can go to this exam to have another shot at passing the course. If you've passed the course but you don't pass the hurdles, you also get a SUP exam. It's your responsibility to be available. It's given that it's like the Friday before semester starts back, hopefully you'll be around by then. I very much appreciate how tricky it is when you don't know the exam date in advance and you book your flights to visit your family 6 months in advance because you don't have a lot of money and then the date. But hopefully that will all be good. The page is loaded. So back to special consideration. Just a quick overview of this. If for some reason you are sick or whatever and you can't do an assessment task, you can apply for special consideration. This is for all university courses, not just this. You apply by filling out a form on like My UNSW and so on. You've got to have things like documentation from a doctor or other relevant person. You go to the website, you put it in, and then the lecturer will assess like, you were genuinely sick and so give you an extension on the assignment, or like you were genuinely sick and missed the exam, so you can do a SUP exam. So that is a thing that you can do if you ever miss an assessment task for some legitimate reason like that. Cool, so the SUP exam itself, come on, will be similar to the final exam but won't give you a skeleton. Friday before that. If you can't go to the SUP exam, you'll fail the course. And your teller won't give it at a different time. All that sort of thing. So, come on. Here we go. The badge. Andrew Taylor's thoughts on things that were bad about COMP1511. It's hard to get started with coding when you haven't got any coding experience, and it'll be even harder when you have 10 weeks in total for the term. He didn't use lecture time efficiently, more integration of tools. The labs got really hard right before the census date. But the good things about the course, the tutors were great, the students were great, you're all great. Most of you have learned a lot from the labs, the tests, the assignments, right? Like, the best way to learn something like programming is to do programming, right? And so the labs, the assignments, the tests have all been this great opportunity for you to actually learn programming, and you have learned programming through them. You should do my experience and give feedback on all of your courses because that's a good thing to do. We also have a COMP1511 specific survey later on. Please do it. The last slide. Good luck on the exam. I hope you get the mark you deserve. I know many of you have worked very hard. I hope you've been rewarded with an understanding of computers and programming. I hope you do interesting and important things in the future. Cool. So that is all of Andrew Taylor's exam slides. Are there any questions about the exam? Yes? So in the first 35 minutes, you can't do any practical coding. You can't write code with a compiler and a text editor. But then after that, you can. You can't, so in the first 30 minutes, you physically cannot access a terminal or a text editor. Like, they are not existing. Cool. I don't know. You might be allowed to. So in the first 35 minutes, you are working on part 1, which is there are questions to solve, but they're not coding questions. Shh. It was much more effective. So in the first 35 minutes of the exam, you're working on part 1, which has the theory questions, so you're not actually writing code in a compiler with a text editor. Like, the exam environment does not let you access a compiler in the first 35 minutes. So you'll spend that time working on the theory questions, and then after that point, you can then use a compiler, use a text editor to write the code for part 2. What happens if you do well in the course and then make a mistake in one of the hurdles? If you pass the course but not the hurdles, you can do the SUP exam and have another shot at the hurdles. I'm not sure what the threshold is for passing the hurdle if you don't quite pass the question. I'm not sure if you have to completely pass the question, but you will be given chances to pass. If you have a bad day in the exam, but you're a good programmer, we'll make you pass somehow. Yes? If you pass the hurdles and you get 51% in the course, can you choose to reattempt the exam? No, sorry. Is that a question or a no question? Sorry. Will you have to make linked lists in the exam? I don't think so. Certainly for the linked list hurdle, you won't have to change any linked lists. You'll just have to do something that involves maybe looking through 2 linked lists or something. Cool. Yep. Sorry. How are the marks assigned for the questions? Are they spaced out equally? I'm not sure, sorry. Yes. So in the theory exam, will there be questions like what's 17 and binary, did you say? So I think the theory exam questions will be along the lines of try and understand this code and say what it does, or what it prints out, rather than theory questions like that. Is there another question around there somewhere? Yep. Will there be lectures tomorrow? I don't think so. What's going to happen is Andrew Taylor's going to send out an email with the resources that we would have taught today, and we're doing the exam lecture today instead of tomorrow. I believe he sent out an announcement about shoots and labs and stuff. Cool. Are there any more questions about the exam? You can also ask questions on the course forum where Andrew Taylor can give the official answer. But if that is everything, let's take a break. So make sure if you have questions, ask them in the, we'll do revision in the second half, so post the topics or questions you have in that Echo 360 page thing. And otherwise, timer for 10 minutes. Get up, dance around, rest your brains. Okay, hello again. Hello, 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 hello. So, with the question thing, there have been a lot of very different questions, and I don't really know what you guys want most overall. So if you can go to the Echo 360 thing, you should get a screen like this. I think it looks like this. I think you go to this button. Maybe you know how to access this better than I do. Yeah, you just click it. Anyway, you can see those. Now you can't see them. But if you go to this button up here, you can ask a question. You can post anonymously if you want, but I can see who you are, so it's anonymous to you guys, not to me. But then you can vote on the questions. So if how many of you are, let me try again, how many of you are able to access this? Like 3 of you, okay. Those of you who aren't, have you tried accessing it? I don't know, there are lots of very different questions to answer, and I sort of don't know which things do most people want. Questions are happening. Someone asked a question. So I'll give you 30 seconds to ask questions, maybe. So who can't access this at all in any way? If you go to echo360.org.au, or you can go via Moodle. You shouldn't have that problem. I will have that problem. It's back. Maybe. But you should have a thing. You won't have all of these, but you should have, we're in one UGB, and then all classes, and then today's one. This one here that says is recording, then if you click on that, it should get you to it. then over here. I see one question has 4 thumbs up. Can I sort by number of votes? I can't sort by votes. Oh well, whatever, the system is fantastic. I'll answer the easy one. Will sorting and searching through values be tested in the final exam? You might have to do this in one of the hardest questions, but you won't have to do this in one of the easy questions. Cool, that question is done. This is very popular, unit tests for assignment 3. I can give a very quick answer. The difference between char star star and char star something square brackets is that they're basically the same thing, because arrays are magic. I think unit tests for assignment 3 is pretty popular. Do I have this in here? Isn't it great living in the country with fast internet? There were a couple of really good ones that Oh, you can see people's names. That's not good. I think this is one of the good ones. Okay, so in terms of writing unit tests for the assignment, right? Generally, if you think back to the assignment 2, intensity, when you wrote unit tests for that, your functions would take in an array of cards usually, and then return like, is the buffalo in my hand, or like, do I have any calves, or whatever. And for those, you can very easily make an array, like, make an array as a test array that has card values, give that to the function, and assert that it gets the right answer out. In order to do that for this assignment, you would have to like create the entire world and make all of these structs and set up all the stuff, which we don't expect you to do because it's really hard, right? And that's why the fruit bot input thing exists. The best way that I've seen to do it is one of the students suggested, like, could we take in a file name? And so have our unit tests be like, if the file name was world0, then assert that this function here gives us output, right? So your tests, rather than making a world yourself, you read in the world from a file, and then you go, based on this file, I know the answer should be this, and assert that you get that. That's the only way that I can think of that you can do unit tests for this easily. If you can't do unit tests, it's fine to just describe your testing strategy. Like, describe in words, how did you test that your code was correct? Right, hopefully you did something to, like, hopefully you didn't just write code and hope, no, cool, it's right, I'm just gonna submit it, life is good. Like, hopefully you did something, you experimented with stuff, you did some testing yourself manually or whatever to see if it was correct. Write about what you did there. If you can, then you can make unit tests by maybe reading in a file name and then testing things from that file and so on. But we wouldn't expect you to do that, I don't think. It's a really clever idea though. I don't know if that satisfactorily answered the question. The answer is basically it's really hard to write unit tests, so it's fine to just talk about in a comment what you've done. And then the best way that I've seen to write unit tests is scan in a file name and assert that the answers should be what they should be for that file name. Is that satisfactorily answered? Okay, so people asked if I could go over file manipulation. Do you have any specific examples or questions of what you want to know about file manipulation? Okay, for lack of specific questions, I will just talk about everything. So, in terms of file manipulation, right? You've seen printf and scanf, like normal printf, normal scanf. I hope you're feeling happy with printf and scanf, because it's been like 13 weeks of printf and scanf now. If I move that, it'll sound better. So normal printf and normal scanf will print and scan from the terminal, right? So I can type stuff into the terminal here, and it'll go into my program with scanf, and I can print things out with printf, and they appear in the terminal. But sometimes it's useful to be able to put things in files instead of just the terminal, right? And so there are sort of two ways we can do this. Either we can directly work with the files by opening them and manipulating them inside the code, or we can work with them by making the terminal do the hard work. Okay. Let me try logging into this computer. Okay, cool, VLab exists. We have a VLab. So, file manipulation, right? We're happy with standard printf and scanf, I hope. I hope we're happy with standard printf and scanf, but it's useful to work with files sometimes. So there's two ways that we can do that. Either we can print into a number. Cool, so beautiful program here. Printf, enter a number, scan a number, print out your number was this. Files.c, cool. Enter a number, 100, your number was 100, cool. So one of the ways we can work with files is by letting the terminal do all the hard work for us, right? So I can say input file number 1000. And so I've made myself an input file. Cat is a Linux command that would just, like if you cat into a file, it'll just put the stuff in the file. Input file. Oh no, what have I done? I don't think I wanted to do that. I did not want to do that. Okay, like I said, we can do this stuff. So I've made an input file with the number 100, right? Cool, it's an input file, it contains 100. You can see it there, you will believe me. If I recompile it, and then I run it. So if I type the number 100, your number was 100. If I type my program and then which one's the mirror reflection of that for you? Is that less than for you guys? It's reflected. The less than symbol with the name of the input file. Let's make this bigger so you can see it. Let's make it even bigger. Cool, so if I say run my thing with the less than symbol input file, this means get the standard in from the file with input file. Enter number, your number was this. Similarly, I can put the output into an output file. So I don't currently have an output file. If I say run files, put it into the output file, and I'm going to enter the number 1, 2, 3, 4, 5. It didn't print anything out here. That's because it all went into the output file. So we can see the stuff that was outputted was enter a number, your number was this. Cool, so this is one of the ways of working with files. The other way of working with files is to do it directly inside C. So the way that we do this, we need to make a thing called a file star, which stores the information about the file that we're trying to read to or write from. So input. So fopen means open this file, input.txt. The R means for reading. And so this will open the file input.txt on my computer and give the information about it into a file star called input. I can then scanf from it. I can get a number from it like this, but rather than normal scanf, I have to do fscanf to scan from a file. And I give this input, which is the name of the file star that I've made. So if I put this up here, so I'll make my program do the exact same thing, but instead of the scanf, I've made it an fscanf. And so now, when I try and run it, it should not work. So I've run my program and I've got an ascend, deadly signal, illegal array pointer, other operation. What have I done wrong? I'm trying to read from input.txt. Does input.txt exist? No, it doesn't, right? So I can't read from it if it's not there. I can make one, input.txt. I've now made a file called input.txt. Cat will show you the stuff that's in a file to the terminal. It's got 1,000 in it. If I run it again, it's now read from the file. Cool. Is this good so far? I can write to a file by doing the same thing, except instead of R, it's W. W is for write, A is for append. So if you're appending, it will add stuff on. If you're writing, it will delete the file and then write the stuff out to it. So write will delete the existing file and make new stuff be there. Call it output. Instead of printf, fprintf to output. Cool. If I run /files, the enter number is still a printf. The other stuff is not being printed out anymore, but I can see inside input.txt is that, and inside write.txt is the output. Is this all good? What other stuff did you want to know about file manipulation, if anything? Let me see if there are questions on here. To the 11 people who wanted to know about file manipulation, are you happy? Are there still more questions? Yeah? How will this be assessed in the exam? So I think it might be possible that we would say something like, do this thing and get the input from this file called this, or something like, let's do another thing, argv. So another thing, int argc char star argv. Another thing that you'll be asked to do at some point is to work with the command line arguments. If you're working with command line arguments, you need to have the argc argv. If you're not, then it doesn't matter if it's there or not. So we might do something like get the file name from argv1, write to the file name argv2. So with this sort of thing here, I'm now opening the file that's given to me on argv1 and writing to the file that's given to me on argv2. And again, if I do this and I don't have the files, it will get grumpy at me. Files, Cool, and it's complaining at me because I've tried to open a file that doesn't exist because I haven't given it any command line arguments. So I should have gone if argc equal to 3, do the stuff. So now if I run it, I've checked if argc is 3 because I haven't given it things, it's not 3, so it hasn't done anything. If I run it with input.txt, blah, output, it's worked. Cool. So the sort of things you might be asked to do would be something like write a program that reads from a file that's passed, like we tell you a file name as a program argument, you've got to read that in and do something with it. Cool. Was there a question around here? Someone was waving? No. So a question, I've seen this question quite a lot. What's the difference between the null terminator, the word null, and EOF? Program. So a common question that I've seen on the forum, what's the difference between the null terminator, the word null, and EOF? So the difference between these, this is a character. This is the null terminator that we have in a string. Its ASCII value is 0, but you should use the quote marks null terminator. This is how we say when we're at the end of a string. End of a string. When we have the word null, this is of type pointer. So if we have a pointer that points nowhere, it's a null pointer. You shouldn't say something like, if you have a string, initialize this to 0, right? You shouldn't say like name 0 equals null, because null is a pointer type, and this takes characters. So this is, the compiler will be like, what are you doing? That's wrong, you're silly. Bad. So null is for pointers, and EOF is a separate thing altogether. It's what getchar will return if there's no more input. No more input. So it's important that you use EOF for getchar, you use null with pointers, and you use the null terminator with strings. Cool. People have asked if I can go over malloc. I went over malloc again the other day. Do you want me to go over it again, or did you just not watch that lecture video? I don't know if anyone's going to own up to that. Someone else, can I go over command line arguments? I sort of did just then. I guess I'll do it again. So argc is the argument counter, and argv is the actual arguments themselves. argv0 is the name of your program. Right. So I can print out what argc is, and this is the number of arguments that it's been given. So if I do a loop like this, this is going to loop through all of the arguments that it's given and print them out. So I did not make a mistake in my code. Of course not. Cool. So I've run my program.args. I've given it no extra arguments, but it still has the argument, which is the name of the program, right? If I rename the program from args to like, hello, this is a program, and then I ran this program here without a backtick, argc0 is the name of the program when I run it, right? But I'll call it args, it's a much nicer name. And then if I give it some other stuff, hello there, how are you? argc is 6, it's got the name of the program, and then hello there, how are you? Arguments are separated by spaces. So if I wanted to have this all be one string, I need speech marks. And so speech marks make the terminal make it be one argument, so it's not a C thing, that's a terminal thing. So the arguments now are args and hello there, how are you? So the way to access them is through argv some array index. I know people find this sort of confusing. Char star argv is an array of char stars, which is an array of strings, so it's sort of like a 2D array. Right. So argv0 is dot/args, right? And we had argv1 is hello. So in memory, right, this is going to look like an array that's got dot/arg null terminator, null terminator. So my argv array is this 2D array, right? And if I pretend that I have lots of hellos, really? So if my arguments were like dot/args, hello, 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 then argv is a 2D array. It's an array of arrays. So argv0 is this array here, which contains the characters dot/args null terminator. argv1 is another array, which contains hell null terminator. So you can sort of think of it as like a grid with xy coordinates, if you want to. Argv00 is going to be this dot. That's the 0th thing in the 0th array. If I wanted to get this O over here, that would be 0, 1, 2, 3, 0, 1, 2, 3, 4. Cool. Are there any questions about command line arguments? Cool, so that was a good question. Is it an array of pointers to strings? Arrays and pointers are magical. Where did the person ask that question go? Arrays and pointers are magical. Someone also asked, what's the difference between char star star and char star star? Cool, so int array 10. I have an array, it's 10 big of ints, it's 10 ints glued together. Cool, we're all happy with these. Int array 10. Cool, function. So I can make two different functions that will do the same thing. Function 1 takes in an int array square brackets 10. This takes in an array of size 10. Function 2 takes in a pointer to an int. When we pass in this here, we're passing in the exact same thing. We're passing in a pointer to the memory where this starts. Right? We can't sort of magically know how big an array is, so we need to give it a size. And size. Cool, and so each of these functions can do the exact same thing while I is less than size. I plus plus. Right, so this one's taking in an int array square brackets, this one's taking in an int star array. But both of these are the same thing. When I have the variable array in each of these, that's the memory address of where this array here is in memory. So I can pass in an int star the same way as I can pass in an int array. And both of these will do the same thing. And to prove it to you, function 1, array 10, function 2, array 10, and then it's not going to work, and it'll be really funny because I lied to you. Char star star. Close enough. What's going wrong here? I'll put a new line in for a start. Why have I got all of these weird numbers inside my thing? TCC. So why have I got all these weird numbers suddenly appearing? They're the same weird numbers, so it's doing the same thing. Any ideas? The contents of my array are all these weird numbers. I didn't put these weird numbers there. These are the values that happen to be in memory there when it started out. So I can fix that by initializing it to 0. And then hopefully, cool, I typed in a slash there. So these are equivalent. They're both passing in a pointer to this piece of memory. That was actually ints. Just a start. And so, right, an int array, a char array is the same thing. Except those need to be chars. Cool. So what's the difference between a string and a normal array? Any ideas? What's the difference between like a string and a normal array of some kind? Strings have this one really magical property, which means I don't have to pass a size in. Yeah, exactly. A string has a null terminator. A string is a character array with a null terminator at the end, so I know how big it is. And so I'm not going to need to do these. Equals Andrew, yeah. So this code here is going to make this array contain a, n, d, r, e, w null terminator. Totally changed my prototypes already. I thought. I didn't change, I changed the not the prototypes, yes. See, I've been thinking, function prototypes, like it cannot be that hard to write a program that will make function prototypes for me, surely. And so I should make this program, and then I would never have to forget to make a function prototype again, and my life would be good. While I is less than size. How do I print out a string rather than saying when I is less than size? What's my condition? As long as array I is not the null terminator. I print them out as characters. Char star star. Cool. And so both of these do the same thing. Char star is the same as a character array. And so when we're talking about strings, we sort of use these interchangeably. We can say like a char star means a string. And so we might say, you know, char star whatever, char star array 2 equals Andrew. There are very subtle differences between these, which we can talk about later maybe. But both of these will make me a string that says Andrew. And so when we have this here, right, when we say char star argv bracket bracket, an equivalent syntax would be char star star argv, and another equivalent syntax would be char argv brackets brackets. I don't know if that one works. I'm not even using argv, so you can't see anything interesting. Cool, so I've made my char star argv brackets be char star star argv and printed out argv0. Like it does the exact same thing. These are just two different ways of representing what is effectively a 2D array of characters. In terms of when you would use it, we say char star argv bracket bracket because we'd say it's semantically clearer because it's designed to be an array of strings, right? So to the person reading this, they go, oh, this is an array, right, of things of type char star, so an array of strings. So they're all equivalent in terms of syntax. Cool. What else is here? Okay, what other questions do you have? Someone is still confused about fgets and fputs. So let's talk about that really quickly. One of these had stuff in it. Sure, so if I'm doing fgets, could be 100 big. I can scan into an array using fgets. I think it's the other way around. Puts array. Cool, so fgets will scan in either this many characters, or until you type in a new line, or until the end of the string, or the end of input, like when it's a null terminator. So this line here means it will scan in up to 100 characters, or until I type a new line, or until it hits the end of the input, and so there's a null. If I made this just take in 10 things, and I ran it again, even if I have heaps and heaps and heaps of input, it'll only take the first 10. In terms of using fgets versus getchar, they're pretty equivalent. I would say it might be nicer to use getchar when you don't know how big it's going to be in advance, so you can just read in things, or if you don't actually need to store it. Like if you want to say, I don't know, count the number of characters or something, but you don't actually need to store them for later on, then you can use getchar to just count them. So like, that'll complain to me. You can believe me that you can do that. Are there any last minute questions? That's not a last minute question. I'm sorry. Yeah. One of the tutors has pointed out you can't do argv bracket because you need to have its size for one of them. It can't do two unknown sized arrays. But these ones are equivalent. Well, unless there are any last minute short questions, let's wrap up because we have 1 minute left. So this has been COMP1511. Can I open my slides in time? Race against the clock. It'll do. So, I mean, yeah, this is the end of COMP1511. You will never have to listen to me in this lecture theatre talking to you about this course again, unless you fail and unless I lecture it again. But I hope that you've had a good semester. I hope that you've learned some stuff. I hope that you haven't hated every single part of programming. I hope that you've found at least some part of programming that's enjoyable and you've found this fantastic fun. You know, programming is fantastic. I hope that you've found it